about the definition of the limit. And the best way to talk about the definition of a limit is to draw a curve. So I'm gonna draw a curve. So here's our x and y axis, and I'm going to draw a red curve. Let's let that red curve go like this. And we'll give it arrows. It goes on forever. Unlimited domain. And I want to find the limit at a point x. Okay, so I'm going to draw green grid lines here and here. Okay, and in black we'll label these. This is x. This is our value x. Okay. And this is, the other side would be f of x. Let me move this over a little bit. And it has a height of f of x. Okay. So when we're talking about a limit, we are approaching, we're coming in towards x from the right, and we're coming in towards x from the left, and we're talking about the limit as x approaches some value. And I guess I should probably make this particular x value is going to be c. So let's make it c. This is the x-axis. We're approaching c. So x is actually approaching, x is approaching c from both sides. X is approaching c over here too. And in fact, when I say x is approaching c from the right, I put a little plus sign. And when I say x is approaching c from the left, I put a little minus sign. That's how we indicate. So x is approaching c from the right and from the left. Okay? Now, I'm going to put in some more grid lines because I wanted to say that as we approach c from the right, we never touch c. We never actually get to c. So I'm going to say we approach it like that, but we actually don't come to C. And we approach it also from the left. Okay? As a matter of fact, actually, let me straighten these out a little bit. I forget to use the straightener sometimes. Let me do this. So as we approach C from the left and also from the right, we never actually touch C. So I want to talk a little bit about that. As a matter of fact, we're going to say that we approach C really closely, don't quite get to C, because in fact the distance, we've got this little distance here from where we get from almost C, and that distance, these little distances here, we're going to call them delta, because this is the delta epsilon explanation. I'm going to do a little arrow saying that right there. These distances are delta, and delta as in little delta, okay? That's a delta. In fact, I'll say this. That means delta okay. So in fact, to the left, we're c minus delta, the line x value to the left. This x value here is c minus delta, and the x value corresponding to this vertical line is c plus delta. Okay? And so let's do our horizontal lines that correspond to c minus delta and c plus delta. Okay? So here's one of them. Oh, I want to straighten it out. Okay, and here's the other one. And so let's get these heights. One would be, in fact, what would these be? One would be f, I'm going to make this font a little smaller. The lower one, wouldn't it be f of c minus delta? Right, that's the one. And the one on the top would be f of c plus delta. Okay. Now, by the way, for a limit to exist, in fact, the point c, f of c, does not have to exist. And we're going to talk a little bit about that because we actually never get x equal to c. We just approach it, okay? So I wanted to also say that if the limit exists, in this case, I would say the limit is actually the height. The limit is L, and the limit is the height that we are approaching at x equals c. In this particular case, the point does exist, so the limit is f of c, but it's not always f of c, because I could have a hole at x, at c, f of c. You see what I'm saying? I don't have to have anything there, okay? I just have to be approaching it, all right? In this particular case, I do, and the limit itself is the height of the function at c, okay? And when we talk about the distance here, and also the distance here, the height difference, okay? These are epsilon. Either one of these, they could be two different epsilons, okay? So let me now, using this, let me write the definition. I wanted to give you a visual so that the definition of the limit made more sense to you. Because sometimes they give it to you in the book without this visual, and I think the visual is really helpful in understanding it. I want to make this a little shorter because I want to move this up. So I'm going to make that, let me put a little arrow there. And I'm going to grab this. It's going to disappear for just a minute because I'm moving it up so I can write underneath what the definition of the limit is based on this drawing. Okay? Make that. All right, definition of the limit. Assume f is a function in the neighborhood of is a function in the neighborhood of c. In the neighborhood of c means that the x value is somewhere around c, in an interval including c. And let c and L be real numbers, okay? So c is a real number, L is a real number. The function f has a limit L as x approaches c, that is from the right and from the left. If any given positive number epsilon, if given any positive number epsilon, there is a positive number delta such that the following is true. That if you take x and you subtract c from it, and you take the absolute value of that, now that is the difference between where our x value is and where c is, and that delta is going to be greater than that. In other words, the difference between our c value and where our x value is will always have some space between them, okay? And that's delta. And it has to be greater than 0. So there is some value delta, okay, such that the difference between x and c, and we're approaching c, right? So the difference between where we are in our approach and c is not 0, okay? It's greater than 0, but less than some value delta, okay? And delta is very small. And also to be true is that the difference between f of x, now this x is the x value that's approaching c, right? And the limit, and so I'm going to take the absolute value, is going to be epsilon, okay? So if both of these are true, okay, and this is if the limit as x gets really close to c, if the limit as x gets really close to c of our function f of x, and that's the curve you see above, this is the f of x function. As x gets really close to c, the limit of f of x is going to equal, as x approaches c, is going to exist, and it's going to be L, which is the height of the function, okay? And epsilon can go to 0, okay? It can actually be 0. However, delta will not, okay? And this is the definition of the limit.